Okay, let's take a look at number 2. You've got a picture frame. We don't know the width of the frame. And well, that means that this has to be 14 minus 2x. And this other side has to be 20 minus 2x. And it says that the picture is 160 square centimeters. So 14 minus 2x times 20 minus 2x is got to be equal to 160. Take a 2 out, and take a 2 out of that one. Let's put it out front. And 2 times 2 is 4. So if we divide both sides by 4, we'd have 7 minus x times 10 minus x equals 40. And FOIL out the left side, you'd have x squared minus 17x plus 70 equals 40. And take out, or rather subtract 40, you'd have x squared minus 17x plus 30 equals 0. Well, what two numbers multiply out to 30 and add up to negative 17? Well, that would be minus 15 and minus 2. So x would be 15 centimeters or 2 centimeters. But the picture is only 14 centimeters wide, so it can't be 15 centimeters. It has to be 2. Number 3. Number 3, it says the width of a dock is 4 centimeters less than the length. And it says the area is 12 meters squared. So we'd have x squared minus 4x minus 12 equals 0. And that would factor x minus 6 times x plus 2. So x would be 6 or negative 2, but you can't have a negative length. So the length would be 6 meters, and the width is 4 less than that. That'd be 2 meters. Now let's go to more word problems. This time we'll do number 46. A rectangle is twice as long as it is wide. If the length is increased by 4 and the width is decreased by 3, the new rectangle formed has an area of 100 square centimeters. Find the dimensions. Well, let's fill out the left side. Let's see, 2x squared minus 6x plus 4x is minus 2x minus 12 equals 100. Subtract 100. And then divide by 2. And you'd have x squared minus x minus 56 equals 0. And we can factor that. That'd be x minus 8 times x plus 7. So x would be 8 or negative 7. But we can't have a negative length. So x is 8. So the dimensions would have to be 8 centimeters is the width, and 16 centimeters must be the length. And there's number 46. Okay, go to 8.4 now. And let's see, we're going to start with number 4, determine the nature of the solutions. Remember, that's where you use the stuff under the square root. The discriminant is b squared minus 4ac. And when that's positive, you get 2 real solutions. When it's 0, you get 1 real solution. And when it's negative, you get 2 non-real solutions. Well, number 4, the discriminant would be negative 6 squared minus 4 times 1 times 9, which would equal 0. So we would have 1 real solution. In number 6, this is like x squared plus 0x minus 2. So a is 1, b is 0, and c is negative 2. The discriminant then would be 0 squared minus 4 times 1 times negative 2, which would be 8. Therefore, we would have 2 real solutions. And number 8, the discriminant would be negative 2 squared minus 4 times 1 times 4, which would be 4 minus 16 or negative 12. So we would have 2 non-real solutions. Number 11, the discriminant here would be minus 4 square roots of 3 squared minus 4ac. A is 4, c is 3. So we would have 48 minus 48, which is 0. We'd have 1 real solution. Okay, now the sums product and the solutions sum. For ax squared plus bx plus c equals 0, the solutions product, the product of the solutions, would equal c over a. And the solution sum would be minus b over a. For example, number 12, the sum would be the opposite of negative 2, which is 2 over 1. So it's 2. The two solutions, whatever they are, have to add up to 2. And the product would be 10 over 1, which is 10. In number 13, the sum of the two solutions to this equation would be minus 1 over 1, which is minus 1. And the product would be minus 1 over 1, which is minus 1. Number 14, the sum would be the opposite of that, over 5, and the product of the solutions would be 7 over 5. In number 15, it's written backwards, so let's rewrite it like this. The sum would be the opposite of 1, minus 1 over 2, and the product would be 4 over 2, which is 2. Now let's go to 25 through 30. It says write a quadratic equation whose solutions are the following, and we'll add the condition that we have integer coefficients. That means no fractions and no radicals. Okay, you notice that these two solutions add up to 11 and they multiply to 30. So x squared minus 5x plus 30 equals 0. You notice the sum of the solutions is the opposite of that number over 1. And the product is that number over 1. Number 26, minus 6 plus 1/4 would be minus 23/4. And minus 6 times 1/4 is minus 3/2. So the equation would be x squared plus 23 over 4 times x minus 3/2 equals 0. And if we multiply by 4, we would have 4x squared plus 23x minus 6 equals 0. That equation would have the two solutions. Number 27. These two numbers add up to 4, and their product would be the difference of two squares, which would be 4 minus 3, which is 1. So the equation would be x squared minus 4x plus 1 equals 0. Number 28, the sum would be 10, and the product, again the difference of two squares, would be 25 minus 2, which is 23. So the equation would be x squared minus 10x plus 23 equals 0. Number 29. The sum, if you add these two fractions together, the square roots cancel and you get 2 over 2, which is 1. And the product, well, we have a little more work to do here. 1 plus the square root of 13 over 2 times 1 minus the square root of 13 over 2. At the top we'd have the difference of two squares, 1 minus 13, which is negative 12. The bottom is 4, so it's negative 3. So the equation would be x squared minus 1x minus 3 equals 0. That equation would have those two solutions. Number 30. If you add these, you get 8, and if you multiply them, you get 16 minus 9i squared, which is 25. So the equation would be x squared minus 8x plus 25 equals 0. You notice all of these had integer coefficients. All of them. I'll do one more. Suppose we had 1/2, and 1/4. If you add them, you get 3/4. If you multiply them, you get 1/8. So the equation so far would be x squared minus 3/4 x plus 1/8 equals 0. And we want integer coefficients, so multiply both sides by 8. 8x squared minus 6x plus 1 equals 0. Okay, let's move on to 8.5. And we want to start with number 7. And these are quadratic in form. First of all, you'll notice that if you take the square root of x, write it like this, and then ask yourself, what two numbers multiply to 6 and add up to -5? That'll be -2 minus 3. If you FOIL this out, you will get this equation right here, which means that the square root of x is 2 or 3. Then square both sides, you get 4 or 9. Number 9 is a lot like it. So square root of x here, that's an x. Square root of x there. What two numbers multiply out to -16 and up to -6? That'd be -8 and +2. So the square root of x would be 8 or -2. But a positive square root can't be a negative number. And then you square both sides, you get x is 64. Number 11, it's done the same way, except we have x to the -1. And the two numbers that multiply out to -21 and add up to 4 would be +7 minus 3. So we have x to the -1 equals -7 or 3. X to the -1 is 1 over x. So x then would be -1/7 or 1/3. Number 13, same approach. X to the -1. And the two numbers that work here would be -5 and -3. So x to the -1 equals 5 or 3. But x to the -1 is 1 over x. So x then would be equal to 1/5 and 1/3. Number 15. This is x squared. X squared. The two numbers that work here would be +9 minus 4. So x squared would be -9 or 4. And then going backwards from squaring, you get plus or minus the square root of -9 and plus or minus the square root of 4. So x then would be plus or minus 3i and plus or minus 2. Oops, not an I there. There, that's better. And number 17. Key in on the middle guy there, x squared. The two numbers that work here are -2, -3. So x squared is 2 or 3, making x plus or minus the square root of 2 and plus or minus the square root of 3. (19). This would go x to the 1/3, x to the 1/3, Two numbers that work here that multiply out to negative 48 and add up to 2 would be plus 8 minus 6. So x to the 1/3 is minus 8 or 6. X then is minus 8 cubed and 6 cubed. So x then would be, let's see, 512 minus 512, and 6 cubed, which is 216. Number 21, this would go x to the 1/3. Two numbers that work here would be minus 4 and minus 5. X to the 1/3 equals 4 or 5. Now, x to the 1/3 is the cube root of x. And the opposite of cube rooting is cubing. So x would be 4 cubed, which is 64, and 5 cubed, which is 125. Number 23 would go x to the negative 2. And the two numbers that work here would be minus, so let's see, what would it be? Minus 6 and minus 3. So x to the minus 2 is 6 or 3. X to the minus 2 is 1 over x squared. So x squared then would be 1/6 and 1/3. That makes x equal to plus or minus the square root of 1/6 and plus or minus the square root of 1/3. And we simplify, that'd be plus or minus the square root of 6 over 6 and plus or minus the square root of 3 over 3. 25 is just like it. So here we go again, x to the minus 2. X to the minus 2, the two numbers that multiply out to 81 and add up to negative 18 would be minus 9 and minus 9, perfect square. So x to the minus 2 is 9, which is 1 over x squared is 9. So x squared is 1/9, which means that x would have to be plus or minus 1/3. And that ends that section. So now let's go to 8.7. There's two 8.7s, 6.9. And this one we will start with, it's this handout, which is titled 8.7, 6.9. Number 1 says find the constant variation and equation of variation where y varies directly with x. That means y over x has got to be a constant. Plug in y and x. I'll give you your constant. So k is 16. Therefore, y over x is 16. So we found the constant of variation and the equation. 2 is just like it. Y varies directly with x. And that has to be constant. So let's see, y is 8, x is 20. That makes our k 2/5. And that makes the equation y over x equals 2/5. So we found the constant of variation and the equation. Here we are, number 8. This time, y varies inversely with x. So y times x is k. Plug in y, plug in x, and that will give us k equals 6.4. And that would make our equation yx equals 6.4. Number 10. Y varies inversely with x. So yx equals k, plug in y and x, and you'd have 6 times 10 equals k. K is 60. And that makes yx equal 60. Number 13 says that current varies directly as voltage. And when 12 volts are applied, the current is 4 amps. So we'd have 4 over 12 equals K. That makes K equal to 1/3. And so I over V equals 1/3. And we can predict the current when 18 volts are applied. So plug in 18 for V. And that would be I over 18 equals 1/3. Which means I would be 6 amps. That's number 13. Well, we need to erase some of that so we can do number 14. Number 14 says the current, I, varies inversely as the resistance. So IR equals K, and I is 1/2, and R is 240. So K then would be equal to 120. That makes our equation IR equals 120. Now we can predict the current when the resistance is 540, so plug in. And we'd have I times 540 equals 120. So I then is 120. There, clean up that mess. 120 over 540, which reduces to 2/9. And let's see. That would be amps. 2/9 amps. Okay, that's number 14. And I believe we're done with that one. Now let's go to the last one, 8.7, quadratic variation. Number 1. Y varies directly as the square of x. So y over x equals a constant. Plug in y and x. So you can see that k is 3. That means our equation y over x squared is 3. Number 3, y varies inversely as the square of x. So yx squared equals k. Plug in 2 for y and 3 for x. And you see k is 18. So yx squared is 18. Number 7 says y varies jointly as x and z. That means directly with x and z at the same time. Now we plug in, so we have 63 for y and 7 and 9 for x and z respectively. And that's going to make k equal to 1. So y over xz equals 1. Number 9, y varies directly as x and inversely as z. And that's going to equal k. So now plug in, you'd have 3 times 20 over 5, which is k, and k then would be equal to 12. So yz over x is 12. Number 11. Y varies directly as x and inversely as the square of z. And that has to equal k. So now we plug in 6 times 3 squared over 27. That would be 6 times 9 is, let's see, 54 for the top, 27 for the bottom, that's 2. That's what k is. So y z squared over x equals 2. And I believe that finishes chapter, oh no, there's one more. Number 13. It says y varies jointly as x and z, and inversely as w. So now we plug in, we'd have 4 times 3 over 2 times 6, that'd be k. Well, k is going to be 1. 12 over 12 is 1. So our equation will become y times w over x times z equals 1. Now we have finished chapter 8.